everyone, Dr. Nat here. So we are doing chapter 16. I'm just going to do a little recap before I go on to the next new topic. So we have learned about Coulombs Law, right? And Coulombs Law describes electric force. And Coulombs Law is a little bit mouthful for me because I always imagine that I'm talking about a coulomb, I don't know, it kind of sounds similar. But anyway, so Coulomb's law talks about the electric force, right? So what do we know about the electric force? Now, if we have a bunch of charged particles, let's say I have 3 charged particles. So one is positive, one is negative, one is positive, and it doesn't matter really. So Coulomb's law says that the electric force must be along the lines connecting the charges. It must be along the lines that is connecting the charges. So if I had another charge somewhere up here, right? It's a negative, I don't care what it is, it's a positive, it's a negative, whatever. So if I wanted to know the electric force, the direction of the electric force, the first thing that I should do is connect a dotted line to the charged particle. Okay? But tak payahlah, kita buat 3 dulu. Okay, so we have 3 charged particles. The first thing that you should do is, while I try to erase this, is joining them together by a dotted line. Why is this important? Because we are going to deal with electric forces in 2 dimensions, and drawing these dotted lines will help you. Okay, trust me on this one. Okay, so the next step is to identify whether they are attracted or repelled. So determine the direction of force by attract or repel, by deciding whether they attract each other or repel each other. Okay, so let's try that here. So the first thing here, I have let's say this is Q1, this is Q2, and this is Q3. So Q1 with Q2, positive with a negative. Now, like charges repel, which means that different charges will attract. So Q1 will want to go to Q2 because Q1 is attracted to Q2. And what about Q2? Q2 is also attracted to Q1 because, hey, Q2 is a negative, Q1 is a positive, they are different, so they are attracted to each other. You know, different is good. And what about Q3? So Q1 looks at Q3, oh, we have the same charge. I don't want to be associated with this guy, so he will repel. He doesn't want to go here. He doesn't want to be attracted to Q3, right? So he should go the other way, but it should be along the dotted lines. Now, I forgot to mention to you that the dotted lines can be extended, which means that if it is going to be repelled, it should be repelled along the dotted lines as well, okay? So Q1 looks at Q3, we have the same charge, I don't like you, and then Q2 looks at Q3, oh, we have different charges, I am attracted to you, so I am going to go this way along the dotted lines. And then what about Q3? Q3 has feelings too, so he wants to decide what's going on as well. So Q3 looks at Q1, okay, we have the same charge, not really my type, so goes over here. He doesn't want to be attracted, right? He wants to go the other way. And then Q3 looks at Q2, okay, we have different charges, so I'm kind of digging this Q2. Now, what I have drawn here is the forces acting on each charge. So if I were to label these forces, let me try using a color that is visible to everyone's eyes. So this guy is due to Q2, right? So I should label this as F on 1 by 2. And this force over here is by Q3, so F on 1 by Q3. And what about the forces over here? So Q2, I have 2 over here, so this is the force by Q1, so this is the force on Q2 by Q1, and this is the force on Q2 by Q3. And what about this one? This is the force on Q3 by Q2. And the same thing over here. This is the force on Q3 by Q2. Okay, so what have we here? I have labeled the forces, and we know so that we know that the contribution of each charge goes where, right? So if I just look at this diagram randomly and I look at F32, okay, I know that this is the force acting on Q3 by Q2, right? Okay, now take a look at F23 and F32. F23 and F32, they have the same number combination, right? But the numbers are switched, which means that the direction of F23, if it's going down, sorry, let me rephrase that. The direction of F23 and F32 should be opposite. This is direction of force, and it should be equal. Should be equal. Because why? Because this is based on Newton's third law. If this dude is exerting F1 to Q2, sorry, if this dude is exerted F1 by Q2, this dude is exerted by the same force by Q3 but in the opposite direction. So these two forces, let me write this as F2. So these two forces are the same magnitude but in opposite direction. The same case over here, F12 is equal to F21, but they are in opposite direction. And F13 is the same as okay, I labeled this wrong. F13 is the same as F12, sorry, F13 is the same as F31. The magnitude is the same, but the direction is different. This is based on Newton's third law. Which is, let me Google that. So I Googled it, and Newton's third law states that if an object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A, which is exactly what we have seen so far happening, right? Okay, so first thing first, we have to draw a dotted line connecting the charges. Second, we determine the direction of the forces. What is the next step? The next step is finding the magnitude of the force. Okay, so I've written find the magnitude of force, and we know that the magnitude of an electric force is given by the Coulombs Law equation, which is F equals to K Q1 Q2 over R12 squared. Okay, so if this is my equation, I am actually determining the force for F12 or F21. They should have the same magnitude, but the direction should be different. If I wanted to find the force for F13, this should be changed by changing this guy over here. So F13, F13. And the magnitude is the same for F31, except that they are in opposite direction. Okay, so your equation, the basic one is F equals to KQ over R squared. The magnitude depends on the charge that you are looking at. Okay, so if it's 1 with 3, if it's 1 with 2, if it's 3 with 2, you have to be aware on that. Okay, and the last step would be finding the resultant force acting on the charge. So let me write that down. Find the resultant force. Find the FR for each charge, or depends on your question. If they are asking about a single charge, then find the resultant force for that particular charge. Okay, so what is a resultant force? Right? I know we've learned this in semester 1, and I know you forgot about it, so let me just repeat myself. So the resultant force should be in between, okay, in between the forces acting on the charge. For example, we have F13 and F12 acting on Q1. So my resultant, sorry, I'm getting a lot of emails. So my resultant force should be between these forces. So that should be like a guide for me, right? I want to know what is the exact angle, but I want to like predict the how should the resultant force look like, so that I can, you know, make sense of it. And my resultant force for Q2 should be between F21 and F23, so it should be over here. I don't know the magnitude yet. I don't know the direction of my, I don't know the angle specifically, but I just want to know in general. Okay, so this is where my resultant force should be located. And the same case for charge Q3, the resultant force should be in between my forces. Okay, so if I were to label this, I would say this is F1, my resultant force acting on charge Q1. This is F2, and this is F3. If I were to write this in an equation, so F1, let me use how do I say this? A smaller pen. So F1 vector is equal to F13 vector, F12 vector. Okay, so F1, the resultant on the resultant acting on charge 1 is F1, and F1 vector is given by the summation of vector F13 and vector F12. And we call this the superposition principle. You don't have to know the name, but I'm just throwing it out to you guys in case you want to Google it. Okay, and what about F2, the resultant force acting on charge 2? So the same thing that we should do is F21 plus F23. So that's my equation. And F3 is F31 and F32 vector. Now vectors have magnitude and direction. If they are not in the same direction, let's say we are talking about F13 and F12, F13 and F12 most obviously significantly have different directions. So don't tell me that you can add F13 to F12. They have different directions, so it means that I cannot add them together. I have to resolve them. I have to resolve my F13 into my X and Y components, F12 into the X and Y components, and then add the X components together and the Y components together, and then find the magnitude. Okay, you know the drill. So let's do an example. Okay, so we have a question here. Find the resultant force acting on Q3. So we have 3 charges, same case like before, but now I'm only interested to know what is the resultant force of Q3. So what is the first step? Oh, I forgot, I already have it here. So the first step is to draw the dotted lines, right? Do not forget the dotted lines. And the next step would be to draw the direction of forces, and you decide that by determining whether it is repelling or attracting. Okay, so I want to know what is going on Q3. So Q3, how do you feel about Q2? Oh, I'm attracted to her, so going there. Q3, how do you feel about Q1? I am disgusted, so repel. So this guy is this force is F on 3 by 2, F on 3 by 1. So we have 2 forces. The resultant should be around here. Sepatutnya lah. Okay, so this should be F3. Next step is, what is it? I forgot already. Let's see the slide. Determine the direction. We've done that. Find the magnitude of the force. Find the magnitude. Okay. So the magnitude of the force is F. Whoa, why is it so sing it? So F3 vector is. Oh, sorry, we are not. We are. Let me just write the equation first. So F3 vector is equal to F32 vector plus F31 vector, and I want to know what is the magnitude for F32 and the magnitude for F31. So F32 is K Q3 Q2. I'm just referring to the numbers on this F over R32 squared. And the magnitude for F31 is KQ3. I'm just referring here, Q1 over R31 squared. So that is in my magnitude. What is the next step? Find the FR for each charge, or in this case for charge 3. Now that we have the magnitude, I want to know what is the direction. Okay, so using your geometrical skills, you need to know what is, let me remove this resultant. You need to know what is the angle of F32 and what is the angle of F31 with respect to the x-axis. So this is angle 1, this is angle 2. Okay, and before we can proceed with resolving it, we need to roughly estimate what is the direction of our x components and y components. Okay, so let me do that here. Let me use a different color. So F32, my x component should be around here, F32x, and the y component should be around here, F32y. And for F32 force, my x component should be here, F31x, and my y component should be here, F31y. Okay? Now we know that to the right, typically we say this is a positive, upward is positive, downwards is negative, to the left is a negative. And we know here that F32x component is positive, F31x component is positive, and this guy is positive going upward and negative going downwards. Okay. So now let's put that in our, why is everything so singit? Yeah. I try again. Okay. Okay, tak singit tapi lagi teruk, but it's okay. X component and my y component over here. Okay, so I have F32 magnitude over here. So assuming I know what the value is, do that yourself according to your question. This is just like recap, okay? So F32x component should be F32 cosine theta 1, the angle between F32 with the x-axis, and angle and the direction should be to the right, and this is a positive. What about the y? The y is positive as well, F32 sine theta 1. And for F31, the x is positive, F31 cosine theta 2. So this is the angle. If they have the same angle, that's fine. But in case they have different angles, then your angle should be different. So F31 cosine theta 2, and you know the drill, this is a negative, it's going down. So F32, what is this? Sine theta 2. Okay. And then now that we know the x components and the y components, I can add my fx for 3 as f32x plus f31x. And then f3 for the y components is the summation of the y components of f32 and f32 and f31. This is f31. So f32y minus f31y. Okay, so this is my f3x and f3y. Now the next step after resolving this and then adding the x components together is finding the magnitude of the resultant force, right? So F3 is, let me use a different color because it's a different step. Just use green. Okay, so my resultant force, so this is the first step, right? This is your second step. Magnitude is your third step. Resolving this should be your fourth step. And then, oh wait, this should be under number 1. So this is number 2. This is number 3. Number 2 is finding the magnitude, right? Number 3, resolving it. Number 4 is finding, like adding these components together. Number 5 is finding the actual magnitude and direction. So F3 magnitude is F3x squared plus F3y squared. Okay, so that is your magnitude for F3. What about the direction, which is theta 3? Theta for the resultant force is with respect to the x-axis always. Okay, so this is the inverse tangent of the F3y component value over the F3x component value, and the angle you get with this equation is with respect to the x-axis, always x-axis. Okay, so if your resultant is below the x-axis, then it's below the x-axis, it's fine. Okay, so but in this case, I don't know, maybe it's along, I don't know, it's too close to tell. Okay, it can be either above the x-axis, below the x-axis, or it can be along the x-axis. And if it is along the x-axis, it means that my y components should be equal to a 0. Okay, if the resultant is along the x-axis. Okay, so we talked about force. What about electric field? Okay, so what is electric field? Now, assuming that I have like several charges laying around, I don't know why, but they are laying around, and each charge has a certain electric field. They have their own electric field. For example, charge 1 has this electric field, charge 2 has this electric field, and charge 3 has this electric field. So I'm going to label this Q2, Q3, and this guy is Q1. Now, the closer you are to the charge, the stronger the E. The stronger the electric field. The further you are away from the charge, the weaker your E. The weaker E. Weaker E. Okay? So you can, so with that said, the circle that I draw is imaginary. It is actually extending to beyond infinity. I mean, not beyond infinity, up to infinity. Okay, so the electric field extends up to infinity, but it gets weaker with distance. Okay, so you can imagine if I were to say, okay, so what's the electric field at this point? I want to know, hey, if I'm standing over here, what is the electric field that I can feel from these charges, right? And I told you the electric field extends up to infinity. So, okay, so I want to know what is the electric field at this point. Am I a charge? No, I'm not a charge, but I want to know what is the electric field that I'm feeling. Okay, cool. So before we can solve for this question, which is what I'm feeling, I need to know what is electric field and what is the equation, right? Okay, so let's do that. So electric field is actually, drum roll, is actually force over a unit charge. So this unit charge is called Q naught. It is a negligible in value, is super small, and it is always a positive charge. And we call this Q naught as the test charge. Positive charge. So this is called the test charge. Now, what does this have to do with what I'm feeling over here? Since I'm not a charge, I need to place a imaginary charge, which is called the test charge, over here for me to know what is the electric field acting at this point. Is this charge going to interact with Q2, Q3, Q1? And the answer is, let's find out. Okay, so if I wanted to know what is the force between Q3 and the test charge, which is super small, let's say the value is 1 times 10 to the 30 coulomb. So it's super small, right? Okay, so if I wanted to know what is the force between these two, the test charge and Q3 charge, so F3 test charge is equal to KQ3 test charge over R, distance between charge 3 and distance between test charge, so 3T. What is the value for the test charge? This is arbitrary, okay? It's 1 over 10 to the 30. So it's like super small, and this makes it close to a 0. So the answer is, are there any force acting between Q3 and the test charge? The answer is, it's close to a 0, so we can neglect it. And plus, the test charge is imaginary to help us solve for the electric field. So it's there to help us calculate things. It's not there as a charge. It's not really a charge. It's imaginary. Okay? So I hope that's clear. Don't get confused. Okay, so with that said, what is E? Jauh gila pusing kan? Tak sampai-sampai lagi equation. Okay. So E is F over Q naught. Q naught is your test charge. And we know that F is KQ over R squared. And we have this Q naught over here. So Q with a Q, it cancels out. Coulomb with Coulomb cancels out. So I am left with KQR squared. R squared is the distance between the charge in question with the test charge. So the distance, if I'm talking about charge 1, so this is the distance. Pretty far. So so this is R1 lah. Let's say it's R1, okay? So if I'm talking about charge 1, this equation should be about Q1. It's KQ1 over R1 squared. Remember, the test charge value is negligible. We want to know what is the electric field exerted by charge Q1, which means that my equation should have Q1 in it. So KQ1 over R1 squared. If I wanted to know what is the electric field exerted by Q2 on the test charge, same thing. I need to know what is the distance between them, R2, and my equation should be KQ2 over R2 squared. This is the E by 2. This is the E by 1, by charge 1. Okay? So conceptually, this is how we do it. This is how you make sense of things. Now, how do we apply it to solve questions? Let's do that. Okay, so this question, I believe this is part of your lecture. If not, then just stay tuned. So 3 charges are arranged as shown in the figure below. Find the magnitude and direction of the electric field at point M. At point M. It doesn't say it's a charge, it's a point, right? Remember, when we are talking about electric field, when we want to know what is the electric field at a point, we need to put in a test charge. What is a test charge? A test charge has negligible value and is always positive. Will there be force interaction? No. Will there be electric field exerted at that point? Yes. Okay. So find the magnitude and direction of electric field at point M. So I have 3 charges over here, which means that each charge will exert their own electric field. If this is Q1, I will feel E1. If this is charge 2, I will feel E2. And if this is charge 3, I will feel E3. So I will be feeling a summation of E1, E2, E3. Is electric field a vector? Yes, it's a vector, which means that we have to use vectors to solve it. Okay, with that said, we have the values here. I want to know what's going on, so let's do it. So E1, let's find the direction. So I forgot to mention about the direction to you. So this guy is a positive, it's a positive charge, and this is also a positive charge. Determine the direction of electric field. It is the same way on how you determine the direction of force. Okay, Now imagine that I am an imaginary test charge. What will I feel when I meet Q1, Q2, and Q3? Okay, so if I'm positive charge, I meet a positive charge, I don't like this person, I don't like Q2, so I will be trying to repel. I am a positive test charge, I meet this guy Q1, he has the same charge as me, disgusting, so I go downwards. And this is Q3, positive charge, I don't like this is not my type, so I'm going to the right. So this is my E from 1, this is my E from 3, and this is my E from 2. Now we can remove this. How did I know the direction? The direction was determined by my preference, like charges, repel, different charges attract. The same way you decide on a force, but now you are determining the direction based on a test charge. Based on a test charge, which is imaginary. Okay, so this is E2 going to the left, E3 going to the right, and E1 going downwards. Now the direction is solved. So first one is dotted lines, which we already have here. It's basically an axis. Number 2 is direction. Number 3 is magnitude. And number 4 is resultant. Basically, you solve it. Okay, so magnitude. We have E1, E2, E3. Let's find out what it is. E1 is... What is the equation for electric field? It is KQ1. Remember, this is 1, so this should be 1 as well. The distance between charge 1 to the test charge. So 0.5 meter squared. Okay. And what is the value for Q1? The value is 6 nanocoulomb. So nanti kita plug in. So E2 is KQ2. And what is the distance between charge 2 to the test charge? It's 0.5 squared. And then we know E3 is... Where's E3? Is this guy. So KQ3 over 0.5 squared. Sama, everyone has the same distance to the test charge. Okay, so now we want to resolve it into EX, EY, EX, EY, EX, EY. Okay, so for E1 is this dude over here. Kalau tak nampak, E1 is going down, which means that it does not have an X component, it only has a Y component. Okay, so with that said, I know that my my EX should be a 0, and my EY is minus E1, because that's the direction I'm going down. And for E2, my EX is to the left, so it should be a negative. I don't have a Y component, that should be a 0 to the left, which means that whatever value this is, it should be a negative. So this is a negative E2. Okay, and then E3. E3 is to the right, it should be a positive, it doesn't have a Y component. So basically the magnitude of E3 is the X component, and this guy is a 0. Okay, now what is the value of E2 and what is the value of E3? The value of E2 is, I don't know, we need to calculate that. So I found out that E1 is equal to 216 Newton per Coulomb. 9 times 10 to the 9 times 6 nanocoulomb over 0.5 squared. And then for E2 is 108 nanocoulomb, and for E3 is 108 nanocoulomb. Now, these values are the same, but in the X component table, we know that E2 is a negative because it's going to the left, and our E3 is going to the right, which means that it's a positive. And they have the same magnitude, which means that they cancel out each other. So if I were to sum this up, right? If I were to sum this up, this should be 108, and this is 108, and the E1 is, the value is 216. Okay, so summing this E at point M, What is the E at point M? It is the X component for the electric field at point M is minus 108 plus 108 gives me a 0. It has a 0 X component. And the Y component at this point is minus 216 nanocoulomb, which means that the electric field is going down. Okay, so that is the direction of your electric field, and the value is minus 216 nanocoulomb. And then you're gonna ask me, Doctor, what about the resultant force? What about the resultant electric field? Since we only have one component here, even if I wanted to find out what is the resultant, I can do that. Let's do it. So the magnitude of the resultant electric field should be EX squared plus EY squared. Square root that whole thing. EX squared is a 0, EY squared is minus 216, square that, and then you square root that again, which just gives me 216. And what about the direction? The direction is given by this arrow, which means that you don't have to use the inverse tangent equation. Okay, so the direction is going down. And the units for this is nanocoulomb. Okay, if your question, if the answer is not a 0, then yes, you have to use this, and you have to use the inverse tangent of EY over EX to find out what is the theta. Okay, it's the same as when you try to find the resultant force and the direction. The same case applies for an electric field. You need to find the resultant and you need to find the direction using the inverse tangent equation. And again, to remind you, when you solve for theta, the theta will be with respect to the x-axis. Okay, that's it for electric field. Talk to you soon. Bye-bye.